Good morning, good afternoon, everyone, and welcome to this Commsignia webinar, which is about deploying CV2X, especially in reflection of the great news which is around the FCC waiver. Before we jump into the middle of it, let me just share you some housekeeping rules. Anytime, feel free to address your questions during the webinar. You can use the usual tools with this platform, and at the end of the webinar we are going to have a dedicated Q&A session to address all these questions. Before again we jump into this, let us introduce ourselves. Here with me is Greg Horvath, our senior pre-sales engineer. But I will let him to say a few words, a few sentences about himself.
Yeah. Hi everyone, my name is Greg Horvath. I joined Commsignia shortly after the company was founded, so been participating in a lot of projects and been discussing with a lot of customers in different use cases around the V2X technology. So I will be here to share some stories about how this technology can be used for safety and efficiency on the roads.
Thanks, Greg. And I myself, I'm Laszlo Virag, one of the co-founders of the company and CTO. And my role is really to define and drive the vision and the strategy of the company. So why we are here today and what are the important topics? So about the agenda, we'd like to give you a bit of a background, the importance of this FCC waiver, also what is V2X, how you can leverage as a technology solving your problems in your cities, in your roads, in your highways, and also how does it help for car makers and vendors in the US. Also, we will bring some examples from our deployments and from the projects we've been having with many customers and partners out there. And of course, let us kind of give you a sneak peek about the future potentials and how you can build up gradually on this platform, whether it's safety, efficiency, or sustainability related problems and solutions, leveraging direct cellular V2X communication. So about the company, we are fully dedicated to cooperative technologies such as cellular V2X and V2X communication. We are really strong in automotive, infrastructure in smart cities, and also in micromobility. So that's really in our DNA, communication, cooperation, and with those technologies to solve real-life problems and providing real-life solutions for that. So first thing first, Greg, can you please tell us a few words, a few facts about CV2X? What is CV2X? What are the key benefits and main differences between CV2X direct communication and 4G, 5G kind of the cellular or cloud-based communication?
Yes, of course. Thank you, Laszlo. So CV2X stands for Cellular Vehicle to Everything Communication, which means vehicle to vehicle and vehicle to infrastructure communication, which is a direct way of communication which happens in real time. So it's best for safety use cases, while 5G and 4G are using the mobile network, so cell towers are needed. It's more long range. So CV2X in general is targeted for safety and efficiency communication, which is direct between participants and low latency to be applied for really safety critical use cases where milliseconds really matter.
And why is it important the fact that you can operate this without any kind of infrastructure? So if you can elaborate on whether this works between two cars or kind of standalone ad hoc modes.
Yeah, let's take an easy to understand example, forward collision warning. You can imagine two vehicles equipped with CV2X transmitters communicating with each other from a half a mile distance. One car can immediately react to the other car's movement or dangerous moves, probably to avoid an accident, probably. So cellular, like regular cellular communication like 4G, 5G is not that suitable for that because of the longer latency in the communication path.
Yeah, but I believe, and as we know, it has its own use cases, so longer term notifications, for example, those can be efficiently relayed via a UU link as well. But when it comes to safety critical applications, we do believe this is the best suited communication technology for car makers and of course for the infrastructure. And yeah, so one aspect to the vehicle to vehicle communication, or addition to that, is the infrastructure side. So this technology can immediately work between an infrastructure component and the vehicle, whether it's from an OEM grade car maker or as a retrofitted fleet vehicle. All right. The next topic I'd like to discuss with you, Greg, is really about the FCC waiver and the importance of that. And before I jump into the technology or technical part of that, I wanted to say a few words about why this is so important. As many of you may already know, we have been using experimental licenses and different frameworks in order to deploy this really great technology out there nationwide. And this is kind of the experimental license, or it was, which is still available. But the main difference is, for example, a car maker can have now a nationwide license to operate vehicles with cellular V2X communication, with some technical limitations, but you will talk about those in a few moments. So this is one aspect and one important fact. And with this waiver, Audi, Ford, and Jaguar Land Rover, they already got this waiver and kind of the ability to roll out vehicles, for example, nationwide. The second is state DOTs can continue the deployment in the jurisdiction statewide as long as they are, of course, compliant with these technical boundaries, or they play between these boundaries or the limits of that. And of course, for the vendors such as Commsignia and other players out there, we have the ability now to certify, for example, our devices against these technical and other requirements. So I believe this is a huge difference which differentiates a proof of concept or demonstration versus a real product. So certification is absolutely key, and that is now possible. And again, the best thing that this joint waiver was created basically by a bunch of state DOTs, car makers, ITS vendors, and other important stakeholders in the CV space. And since this has created a precedent with the template which is created by 5G, for example, with the same parameters, anyone can apply for a similar waiver, and they should get it in a timely manner. But let's discuss maybe these technical parameters. If you can just recap, and on a very high level, if you could introduce these to the audience, that would be awesome, Greg.
Yes, so as Laszlo said, this waiver is very important to give green light to C-V2X-based deployments. It has certain limitations and regulations, of course, which must be met. For example, it states that the upper 20 megahertz of the 5.9 gigahertz spectrum should be used for CV2X. So this is a very important fact that FCC's regulation shows a clear direction to use CV2X technology for CITS safety and efficiency related use cases. And as Laszlo mentioned, as you mentioned, a group of automotive companies, DOTs, were part of this initial waiver, but others can also join with the same conditions, of course, and this is This is assisted by 5GA's template that can be used, so the process is quite streamlined and easy to follow through to get this license and start deploying CV2X.
That sounds great. Thank you so much, Greg. And I believe one important aspect that there's going to be a final rulemaking. The timeline, if I'm not mistaken, that is between 18 to 24 months from now. So that's kind of the roadmap. But no one really expects any significant change regarding this granted framework, with which now we can operate and others can operate out there. And even though something would happen, basically with software updates, most of these equipment and radios can be adjusted to these parameters. But I hope you can confirm this.
Yeah, so most probably the ground rules will remain the same, and some details will be worked out in the coming 1 and 2 years to make the final rules for this technology. Yes.
Thanks. Now that since we have adequate equipment and we've been having these, and now we have a nice framework which is really future-proof, and lets basically state DOTs, cities, municipalities, road operators to scale up the deployments. Can you please share your experience from the real world regarding, what are the typical problems in a US city or in an urban or rural area, because you are the one who works directly hands in hand with the customer, so you have seen a lot, you experienced a lot. So can you please just list a few of these problematic situations or generic problems these partners and customers of us are facing every single day, and for which, for example, this cooperative technology can be a good solution?
Absolutely, yes. So the basic problems, basic traffic-related problems of cities and state DOTs usually fall into two big categories. One is efficiency-related, the other is safety-related. So efficiency-related problems could be badly managed traffic, traffic congestions, inefficient public transportation, inefficient emergency service, and other common services. The other side might be more visible in terms of statistics. It's the death rate and the accident rate on the road. So it's safety-related problems. These are safety-related problems, which are different on highways and different in cities, but both are equally important. For example, highway scenarios could mean high-speed accidents, high-impact accidents, which could be avoided using wide-scale CV2X deployments. As you mentioned, vehicle manufacturers will come out with this, and also fleets can be retrofitted with this technology, so both these can help these situations. The other side is in urban areas where there is very dense traffic. A lot of traffic participants are using the same roads and the same infrastructure, trucks, passenger cars, vulnerable road users, which is a collective term for pedestrians, cyclists, and other users of the road who are not protected by a vehicle. And in many cases, there could be unsafe intersections where a lot of accidents are happening, and CV2X can help collect real-time data on the one hand to interact and react to these situations to avoid accidents, and also it can intervene in real time with equipped vehicles. So this is very important, and yeah, I think these are the main problems as I've seen and heard from our customers so
you
far.
mentioned quite a few problems out
Yes.
there to be solved, and I know for sure that, of course, traffic engineers and cities and the DOTs have been fighting and improving, of course, the system. So one thing I really wanted to highlight is this real-time aspect, which, in my opinion, is really the key and the biggest benefit, that here we have the ability to react immediately and prevent something terrible to happen, as opposed to collecting the data, the information, analyzing the situation and coming up with a plan. And forward looking, of course, we may have the ability to change the layout, the architecture, something with the traffic, and avoid those kind of accidents or fatalities. But if I understood correctly, and of course I'm also in this company and in this field, so the main difference is really catching data real time, extracting useful information and relaying that back to the traffic, back to the participants, giving them the chance to react and helping them. Is that right? Do you see this pattern or this kind of need from partners, from customers?
Yes, absolutely. And what we've seen so far is that efficiency-related problems and safety-related problems come hand in hand, usually. Let's imagine an intersection with inefficient traffic, like public transport buses or snowplows stopping too often at red lights, spending precious time at red light, and at the same time there could be pedestrians in the blind spot being in danger, not seen by the truck drivers, for example. So using this technology can, for example, provide priority to these maintenance vehicles or public transport vehicles to help critical service to be more efficient, and increasing the safety on the roads, for example, letting snowplows clean the roads faster, and at the same time let the drivers be aware of unseen pedestrians, for example, combining this technology with smart sensors. So it's not just about the direct communication and the CV2X communication itself, but it can also integrate with other solutions, other for example, smart sensors, to extend the scope of the whole system. And once there's an initial deployment, there's a basic use case deployed, which can be different for different users, like cities or highway operators. Once there's the infrastructure, they can improve its value by adding new use cases and new features, and integrating further equipment to make it even more efficient and more robust.
Thanks, Greg. I believe this is an extremely great topic and example you brought up. That can be also quite frightening sometimes, because what you mentioned, quite a few useful applications or solutions. And then seems like this is kind of a complicated system, but I believe it's not complicated, but rather sophisticated. So if we step back a bit, how do you see how you can, or how someone can start basically CV2X deployment? So what are the basic focus areas or basic steps or the initial steps in your opinion, or basically based on your experience? So you mentioned buses, snowplows. Can you please share more details about those initial steps, and of course others, and then let's explore, how you can build on top of those applications or solutions.
Yes, sure, absolutely. Usually, when first deployments start with the customer, we go gradually, and we start with one or two key use cases which are most important to that specific client. Let's take transit signal priority, for example. It's about making an intersection smart in a way that if a snowplow fleet is equipped with retrofitted CVTX devices, so they can communicate with the intersection through a roadside unit that uses the same communication, we can give green light to these vehicles when they approach the intersection. As easy as that. These systems existed before using legacy technology. What makes this different and better is that it can provide a lot of other use cases. So we can start with one specific use case like priority, and once the equipment is there, it's up to the client what other use cases they want to add to that.
What are these other use cases?
Other use cases, for example, for public transport buses, these smart intersections can communicate the timing and the state of the traffic lights, so the driver can get a speed advice, and if that's followed, he or she can drive a green wave, which makes public transportation much more efficient, and this way you can save fuel, reduce emissions, and make the overall traffic flow more smoother, so faster, more efficient. And these are all things that can be measured, so it's relatively easy to see the benefits of this technology, which is important, of course. So it must be seen.
Yeah. So if I can summarize, so you start with simple applications, use cases, and you start building up the system, the infrastructure in intersections, highway segments, rural areas, and that platform basically is able to provide much more than the initial goals, such as a transit signal priority or preemption. One example we experienced is basically the snowplow priority, which started as a priority, but ended up kind of a safety or safety-related benefit, because cleaning the snow faster created safer pavement for the public, for the average drivers.
Exactly.
And another step is what you also started to, or already mentioned, this vulnerable road user aspect. So can you please share some details on that, how you can basically upgrade your existing system with minimum additional investment in order to protect cyclists, e-scooterists, and even pedestrians? So what are the ways, what is needed from a customer or a partner's point of view?
Okay, so let's take again the smart intersection concept. So starting point is an average intersection without any CVTX equipment. There's some traffic control equipment controlling the lights. Of course, it can be also optimized. Once the CVTX equipment is added to that, those can be integrated. So these can be integrated relatively easily to get the traffic light information from the controller and communicate it from the roadside unit to the vehicles. And once this is working and the initial use cases are deployed, tested, and running, for example, smart sensors can be added, like a visible spectrum camera that can dynamically detect pedestrians with the locations or cyclists, and the RSU can take this information from the smart sensor and digitalize it and translate it into the language of CV2X and share also this information with the vehicles. So virtually these equipped vehicles can see around the corner, and they can see everything that is seen by the intersection and the intersection sensors. So that can really increase the safety in these areas.
Okay, so basically what you just described, it's a system which can involve non-connected entities or moving objects, such as even pedestrians or non-connected vehicles, into this connected ecosystem, and gives the ability to the infrastructure and also the cars to react basically on this information. Right, so I just wanted to make it clear to the audience that this is kind of the situation here, and this also solves this chicken or egg a kind of situation, because imagine that in a dense or problematic intersection as you described, if you have this technology, you can increase the penetration level for that area with or without having many vehicles or moving objects, CV2X communication. Of course, that's gonna come, but as of today, we can increase with these creative ways of cooperation, we can increase the penetration level up to, I don't know, 60, 80, even 90% for that intersection.
Yes.
And again, summarizing, so basically, we create together with a partner the basic system, the infrastructure for one simple or two simple applications, such as priority. We can evolve that system into safety-related systems, such as the snowplow effect on the pavement. And with additional sensors, we can even upgrade the system to protect the most vulnerable road users out there. And one interesting aspect you mentioned, that there are existing systems already, and equipment and ITS sensors, actuators in an intersection. So do we need to replace those, or can we build on top of those? Such as, the cameras or the lidars or the traffic light controllers, the loop detectors, because I believe that's kind of a common fear of customer that, hey, I've been investing a lot of money, time and effort to build this up, and these are, I believe, great systems, whether they need to replace with V2X or is basically an add-on to that, which can improve the system.
Absolutely, these are more like add-ons. So most of the legacy equipment can be used to be part of a more integrated, bigger system, a more complex system that can provide a lot more services and can provide a lot of data as well that can be collected. It's also very important. And as you mentioned, locally in these areas like dangerous strips of road or dangerous intersections, once equipped locally, the safety level and the efficiency level can be raised. And once the mass production vehicles arrive with CV2X technology, they will right away enjoy these services. So they will get the same services. Not every time, maybe they won't be able to request green light, but they can also receive all these messages from the intersections about detected pedestrians, so they can also see around the corner, just like equipped snowplows or buses, which will be the first wave of these deployments.
Okay, maybe one aspect that with the data and with the information and the ability to communicate and cooperate, it's clear that we can react with another road user. But what about those situations which are not causing imminent danger or threat to someone, but if we are able to detect those, we can highlight, some misbehavior or problem with an intersection. I'm talking about typically, near misses and things like that. So how do you see those kind of applications or situations, whether we can capture it, whether we can highlight it, and if so, how that can be valuable for a user or for a customer?
This is a very good point. So besides the imminent effect of using CV2X for active safety, it's also kind of special sensor in the sense that even though cameras can detect a lot of things, but CV2X is communication based. So it's coming from the vehicle and that information is 100% reliable. So detecting near misses, like detecting which intersections or which parts of the city are most probably
problematic
that could cause a lot of accidents. So preventive actions can be taken by collecting this information, using this 100% real-time and reliable information provided by CV2X, collected in a central location and analyzed. So there's this real-time active safety side of it, and also collecting the data and analyzing it. Cities can make better decisions where to tweak the system, so how to spend the money more wisely, more effectively to get the most benefits out of it.
That sounds amazing. Before wrapping up and going to the Q&A session, one aspect I really wanted to touch base on is micromobility. Of course, you mentioned these ways, involving sensors and digitalizing non-connected moving objects or VRUs. Can we equip cyclists or e-scooterists with this technology? How do you see that?
Yes, absolutely. This is also a very important area, since these users are much more vulnerable, as we call them, vulnerable road users, and it's important to protect them and especially make them visible digitally, so that trucks and vehicles can receive an early warning about close-by cyclists. So yes, definitely, this technology can be deployed in like in e-scooters and even bicycles as well. And the most important factor and most important thing here is to make them visible. So the vehicle that's more protected can consider these vulnerable road users and adapt their behavior to save them and not cause accidents.
Thanks, Greg. Maybe again, just to summarize it, and correct me if I'm wrong. We have a basic infrastructure, basic applications. We built on top of that some safety-related apps. For example, this safer pavement analogy and application. Then we connected smart sensors. Do I understand correctly? If I were to put a CV2X device onto my bicycle or e-scooter, since the infrastructure is already there, the biggest trucks, the snowplows, the buses, and the fleet vehicles, they already have this. I am visible, and I have better chances to survive, for example, a dangerous intersection.
Absolutely, and it's important to highlight that you are visible and they can see you around the corner. So not just visible in the line of sight, like normal sensors, cameras or lidars, but since this is a radio-based communication and sensing, it can use buildings and reflections to transmit the signals behind big buildings or other obstacles, so you can be seen from around the corner.
Okay,
yeah, and
thanks.
That's key.
Thanks. All right, let's then jump into the Q&A section, and we have a question. If you don't mind, I would read it out of loud. So, as an agency waiting to test CV2X, do we need to secure a license to operate the roadside unit? I mean, this is a great question, and that really depends what kind of tests you'd like to perform. But again, one way is getting an experimental license, but the recommended way is really to apply for a waiver and have the waiver. But some tests and experimentations can be done without having these or securing these. But obviously, if that's an outdoor demonstration, testing, experimentation, of course you need to have either the experimental license, but rather and better to have the FCC waiver.
Yes, and I think it's also important to add that once you have the waiver to operate the equipment, there are these certain limitations that must be met. So the frequency band, the 20 megahertz of the upper 5.9 gigahertz spectrum, also the transmit power is limited. So until these are fulfilled, you can test a whole lot of use cases with CV2X.
Yeah, but should you have any other details or questions, feel free to reach out to us, and we would be much more than happy to help and support you with your testing. So the next question is, interested in learning more about the current state of the practice for deployment of CV2X. I believe most of the topics we addressed here and talked about kind of answers this topic. But again, just to reiterate, the typical practice is selecting a few basic or simple, but rather very important problems out there, and basically focusing on those and proving that the technology, the solution is really working and useful. And based on that, we build up gradually more and more efficiency and safety related applications. I hope that addressed that question and that topic. So what are the current situation of VRU scenarios with CV2X in US/Europe? Greg, maybe you have more experience on that, if you want to take that question.
Yeah, we already had some demonstrations around it, and the first small-scale POCs are running with CV2X combined with smart sensors, for example, thermal cameras or visible spectrum cameras. These are all smart sensors, meaning that they can detect objects on their own, so they pass this information to the roadside unit, and the roadside unit can translate it into V2X messages and send it to the cars. We had a very good project in Finland, for example, building a smart intersections with a 360 LiDAR that sees around the intersection, so it can pick up each pedestrian and cyclist from each direction, and once a vehicle approaches to the intersections equipped with the CV2X onboard unit, it can pick up all these signals and visualize it to the driver, so the driver sees everything around the intersection, so can be well prepared for any risky scenarios, and even get early warnings about a possible collision risk with a pedestrian or a cyclist. So these are starting small scale. A lot of testing and measurements are ongoing, but these will be very important. And it's important to mention, I believe, that there are specific funds in the US targeting vulnerable road users, so this will really lift off in the coming years. So we will focus on this quite a bit.
But yeah, thanks, Greg. Maybe on the CV2X side of things, as you mentioned, demonstrations, just to give you a few examples which are public with Audi, with Ford, with Spoke Safety, Qualcomm, and also with other players, we've been demonstrating the usefulness of this technology. Yes. With a setup where we have an active CV2X communication device on either a bike or an e-scooter, but these are not rolled out in high volumes and quantities as of today.
Yes, but the waiver will help.
Yeah.
Deployments scale up, definitely. Yeah.
Definitely. So next question, do I need to apply for a waiver at my DOT, or Commsignia's waiver is enough to deploy roadside units and onboard units? You want to take it or should I?
I leave it for you.
Okay, yeah, so since you need to register locations for roadside units, you have to have the waiver, you as a DOT, and that would really give you the ability to deploy not just a Commsignia device, but any of these devices in your jurisdiction. So I believe this is really the preferred way. For the OBUs, I'm not entirely sure whether that is enough, but better safe than sorry, and apply for the waiver. But I will check it more thoroughly, whether this can be basically covering your needs without having your own waiver. Right. Will the CV2X infrastructure at 5.9 GHz require more complex propagation planning like cellular networks? propagation planning. I'm not entirely sure what's really the question here or the detail. So the main difference between cellular and 5.9 is that 5.9 is really almost a line of sight communication. Of course, there are reflections which can be harmful, and sometimes that can help the communication. So the propagation planning really depends on the environment, whether you have an urban canyon or you are in a rural area. But typically you need to ensure that you have an adequate system, such as, I don't know, 1,000 feet in a city, you have a roadside unit for the infrastructure. But that can be a longer distance or even a shorter one. As opposed to cellular, of course, there you are planning base stations all across the city, which operates on a different frequency range. But here really to have first and foremost line of sight visibility from the infrastructure towards the vehicles. And if you want to ensure redundancy, of course, you should also take into that as also consideration.
Yeah, I think maybe I would add some thoughts to this, if I understood the question correctly. So compared to the standard commercial mobile networks where cell towers are used, of course, the road planning is needed there to ensure the right coverage. With the C-V2X infrastructure, this similar type of planning could be useful at the fixed locations for RSUs. Many things can influence how the signal behaves, like trees can block the signal. The right antennas should be selected for the RSUs to reach the proper distance with planning the
Yep.
radio range and things like that. But we can definitely help with that.
Right. Checking whether we have any other question.
Mm-hmm.
So how long does it take a project from planning to implementation? I believe that's the question. So Greg, since you have seen a lot of real life example from smaller projects up to the largest urban deployment, for example, in Las Vegas and in other locations. So what is your view on that? So how long does it take really from planning to implement? And I know this is not an easy question to be answered, because the right answer is it depends, I know, but as kind of an average project. So if someone wants to deploy something useful, and then preferably he or she or they would like to measure it, so really from planning to implementation.
So
if everything is ideal,
if everything is ideal, it could be like a couple of months, so to say, up to a year, depending on the scale, and of course depending on how well the project was planned when it was when the RFP was opened, and of course a lot of details must be worked out after that in the first phase of the project, and when closing the project, collecting the measurements, the results, these can be used to further optimize. So it's also up to the client how long they want to run this and how long they want to iterate it further. But yeah, typically a couple of months to a year.
Mm-hmm. I'm looking at the next question, and let me just ask. What do you think takes longer, the administrative processes around the project, or really, once everything was delivered, make the system working and operational?
Usually, the longest part is the initial deployment and testing, but also The very first phase of the project, planning everything well in advance, it is good if it gets enough time, so that the whole project could be followed through carefully, and most of the critical points can be cleared out at the beginning. But yeah, typically the deployment, when it actually starts and the planned use cases are being implemented and tested, a lot of fine-tuning could happen depending on the project, on the use cases, and on the locations. Usually that part is the longest.
I read your words, and of course adding my experience as well, and bridging to the next question, which is what should an agency be careful of. I believe I would kind of rephrase that sharing, for example, experiences and findings and lesson learns from one location and one project to another. I do believe that could significantly boost this kind of bootstrap or initial phase of these projects, because we see many repetitive actions and testing. Of course, everyone wants to guarantee that the system is running 100% and everything is completed and measured twice, 3 times, and even more. But sometimes we learn that these exercises have been done many times before. So I would really encourage everyone to get in contact with those who already deployed, who already played and used this system and figured out whether these are great technologies or great solutions or kind of an okay one. What were the lessons learned? What are the future outlooks for that? And again, since we are talking about a cooperative technology, we also need to cooperate among the different projects. I hope this gives you an adequate answer to your question. All right, I believe that these were the last questions. So with that, we'd like to thank you for everyone for joining us today, and thank you so much, Greg,
thank you,
answering many of these questions and sharing your experiences. And again, should you have any questions or any details, feel free to reach out to us. Again, if you have any questions regarding the waiver and how to apply, we can help you. We've been doing that support for not even for our customers, but basically everyone who would like to register a device or plan something ahead. Please feel free to reach out to us anytime. Thank you.
Thank you.